Hey folks, so in this video, I'm going to start talking about data abstraction. So this module is going to be mostly a review for you guys. A lot of it is kind of classical OOP stuff, but then maybe with a little bit more of a focus on clean design. Somehow here, right, our name, the name of this module says a lot, data abstraction. We're going to be really talking basically about the idea of taking data, right, and sort of hiding it from people, right, encapsulate it, making sure that people don't have to worry about, for example, what's inside of an object. All right, so that's our goal. Now in this specific video, what I want to open with is basically reviewing Java objects. So let's take a look. So OOP is something you're already familiar with. You've probably already had about a year of classes on it. So you have heard, right, the term class, the term object. These are kind of things, right, that people start learning even on their first semester of programming, especially if you're doing something in Java, right? Most of you are coming into this class with a background in Java, so you have probably a year of it already. So in that class, right, they basically talk about a couple of things, a couple of key concepts. The first is the idea of a class. Second is the idea of an instance or an object. So let's review this, right? And I know you guys have seen this a little bit already, but just to make sure we're on the same page, we'll go through all of this together. All right, so first of all, right, you have the concept of a class. So a class is something that's basically analogous to like a blueprint or a framework. Basically, it's like the instructions on how to build something. So the typical example people have is they say, oh, a house's blueprints, right, is kind of like a class. Basically, right, it's something that's on paper, right, that's basically just instructions for how to build a house. It's not the house itself, right? You can't live in the house as defined by a blueprint. But if you had the money, you could actually construct it, right? And then it would be something you could live in. Or you could have plans for other things, right? So you could have blueprints of a car, right? Saying, okay, if I follow these directions, right, I can build a car I can drive around, right? So all that's well and good. That's somehow, right, the idea of a class by itself, right? It's a blueprint or a framework for how to build something. It's not actually the thing itself, right? So then, right, we have kind of the natural extension of that, right, which is the idea of a object or the idea of an instance. Basically, what that means is, hey, we have a blueprint for something. Let's follow that blueprint and construct something from it. Now, note that when we construct something from a blueprint, right, when we construct something from a class, we typically have to fill in some blanks because these things aren't always complete, right? So if I have the blueprints for a car, it's probably not going to define for me the color of that vehicle, right? Or maybe what type of wheels I put on it. A few things like that, right, are basically going to be left up to the person who does the actual implementation of it or the instantiation of it, right? When they actually create that vehicle, right? For the example of a building, right? They may not define, what is the color, right? What paint do I use on the interior of the building? What carpet do I pick, right? These things may actually vary because you could even imagine if I had some blueprint, I could maybe use it to build multiple things, right? I could use it to build cars A, B, and C. And if I leave things kind of up in the air, right? I don't define, what the color of the vehicle is. Well, then I'm free to say, okay, this vehicle is red, this one's green, this one's maroon, this one's gold. I have that flexibility still, okay? So one aspect of a blueprint, right, or a framework is that not everything is defined, right? There still are a few things that need to be filled in. And once we fill them in, then we can actually build a thing, right? Then we can actually build that building, then we can actually construct that car. Now a key word here is also the word instance. So while we have instance and then instance. So we say, right, that basically classes are instanced to create objects, right? So that's the process of creating an object. Or we also use the term sometimes instantiation. And the objects, right? Objects are instance of classes, right? So every time I have an object in my system, it has to have been created from some class, right? We can't have things walking around our system, right? Unless they were created from some specific blueprint or from some specific, / framework. It has to come from somewhere. So yeah, there's kind of that relationship there, right? Between blueprint and actual concrete object. All right. So on the right-hand side, I have some things that basically characterize objects. So there's 3 things on the list there: state, behavior, and identity. So let's walk through those one by one. So first of all, we have this idea of state. So I mentioned a second ago, right, it's like, well, I have a blueprint, right? Maybe there's some things that aren't filled in, right? Like, for example, the color of the car. Well, actually, right, if you think about it, the color of the vehicle, it could actually change over time, right? I could go and paint the vehicle, or I could do something else, I could add a decal, whatever. Somehow what this represents is the state of that vehicle object, okay? So every time I have an object, right, I have some sort of data associated with it, right? It's like, this is the way it is, right? It's this color, right? Or it has these wheels, or it has this maximum speed. These are all kind of aspects of a vehicle. And they come into being, right, when I create it from that class. And all that stuff kind of collectively, right, the information tells you, this is the way the world is. That's all state, right? That's kind of, us having, specific properties being known about this vehicle. All right, the next thing we have, right, is behavior, right? So behavior is basically going to have some actual, functionality there, right? So it's saying, okay, a car can do this, right? It can, turn on its lights, right? I can lock it, unlock it, right? There are all kind of different behaviors associated with it. Something like a building, right? Maybe other features are available. For example, maybe you can list all the occupants, right? Like who is in the building right now. Those are all behaviors, right? And that behavior stuff, generally, it'll be the same between the different objects of a class. So a class typically, right, defines some state that's like, well, it's kind of left up in the air. I need to work on it and define, what is the color of this thing, versus there's some behavior. And basically, all the objects, right, the instances class will have the same behavior. That ends up being shared between them. The last item we have up on that list is the idea of identity. So identity just says the following. If I have an object, or if I have two objects, I can basically compare them. I can see if they're the same or if they're different. So I might have the idea, right, it's like, okay, maybe I create, a blue car, right, that's great. And then I create another blue car, right? I should be allowed to have two blue cars in my system, right, that even though they have the same state, right, they've been filled in the same way, they have kind of some distinct identity, right? I should be able to tell them apart, right? Maybe there's something on there, right, something like a unique identifier, something like that. Now for us, typical identity somehow represents, so I have, right, some different objects in my systems, and it's like, well, they maybe are a different memory address, right? I've used the new keyword a couple times, right? They are really, different things. I can tell them apart, right? Even though they look the same, right? They aren't the same thing, right? They are different. You can also think of this maybe just in terms of variable names, right? I can have different variable names for something, right? So I can have two different objects, both identified by different variable names, even if they have the same state inside of them. All right, so some of this is kind of illustrated below in our graphic. So I have here basically a diagram to show the relationship between a class and an object. On top is, of course, a class, which is basically just our blueprint. So we have our blueprint, and then we have basically some information to fill in, right? So what this is basically modeling here is saying we have a rectangle, right? That's going to be our overall class, which is really simple, but it's also something that's simple enough that I can diagram here on the slide. And so this rectangle class basically has these different properties that need to be customized, right? These are the states. This is the state of the objects, right, that will need to be defined. So a class by itself, right, for rectangle, it knows that I need to have a color, a length, and a width, right? It knows that. They're not filled in, right? I don't know specific values for it, but I do know that any sort of object I construct from this class will need to have those things defined for it. So this is our blueprint, right? Our blueprint says, okay, I have, those three things, and I can kind of put them together into, make this rectangle-looking thing on the screen, right, that has a specific color inside. As it is, though, right, I can't actually, so if I just have the class, right, it wouldn't make sense for me to go and say, hey, what's your length, what's your width, what's your color? It wouldn't make sense for me to do that, right? This is just a blueprint. Not everything's filled in yet. It's only once we actually create an object from it that information will be filled in, and we'll be able to ask those questions. So initially, we don't really have something. We just have a blueprint for how to build something. So let's say I now have information. Let's say I have a length, I have a width, I have a color. Then I can actually do something. So I would create an instance, right, of this class, and I get an actual object. Right, so this over here is an actual object. So I've defined that it's, say 1 unit, 1 unit's width, right? Maybe 2 units is its length, and its color is brown. Okay. All of a sudden, I have enough that I can actually take that blueprint and build something from it. Now I can, right, of course, actually go to that blueprint, use it again, and give it different values for that state. So I can give it a different length, a different width, a different color, and all of a sudden I get something that looks completely different. So I get this over here. Something that maybe is, still 1 wide, but all of a sudden it has, 4 in length, right, and is now a green color. And I can repeat this process as many times as I want. Again, I have another example, right, of a different size rectangle with a different color in it. So this is kind of a nice thing, right? All of a sudden I have basically the ability to have some sort of a generic template-y thing, right, that I can then customize based on what I need. So it's like, well, I put in this size, I put in this color, I am able to use it in a bunch of different places. So objects usually what people use them for, right, is when they have something in their system and it's like, well, I need many copies of it, right? Copies of it that might differ just a little bit, right? So when I have kind of these common structures in my program, I'm going to have some sort of an object. So if you think about something like a game, right, maybe you have a bunch of different things on the screen, right, a bunch of different entities on the screen that are moving around your game world. All those, right, could be maybe instances of the same class, right? And the class as well, world entity or something like that. Or you have, maybe you have ASU system for tracking school registration. Well, probably somewhere there's something like a class, well, a class for a class, or I should say a class for a course, where it's like, well, the fill in the blank there for the state is stuff like, the name of the class, the number of credit hours, the instructor, that type of thing. Okay. So anytime you have kind of this repetitive structure, it's like, well, I'm going to have a bunch of different copies of this. They're all slightly different. That's when you want to think about using a class. That's really the kind of the idea that it's trying to encapsulate, right? It's trying to represent, right? As I have this one generic thing, right, with some stuff I can fill in, and then I have the ability, right, to take it, make actual concrete objects from it, fill in the blank, right, and all of a sudden I get stuff that can do work for me. Because remember, all these have behaviors, right? It's not really illustrated here in the picture, but all these, right, might have some sort of functionality, associated with them, right? Maybe they all have, maybe in here I have something like a draw behavior, right? It's like, well, it should know how to draw itself on the screen. well, all of a sudden, all those instances from that class, they'll all know how to draw themselves as well. They'll be borrowing that code from the parent and then using that information you put in about their size and their color to render themselves on the screen. So kind of a very nice thing, right? It gives us a lot of sort of reuse of code. All right, so that's kind of a basic review of objects for you guys. In the following videos, we kind of move forward with our knowledge, right? How do we do this data abstraction thing? How do we really make sure that data basically is only exposed right to people that have to care about it or have to know about it?